table of contents and your notebook. This is our last section of the chapter, so you will take a test either next week, Thursday, or Friday. It goes fast. This goes fast. The first 3 chapters go super fast. They're not very long. So this is words, equations, tables, and graphs. Today, if you're paying attention, this is very simple. Okay, if you're paying attention, this is very easy. So, equation. The equation is something we're going to use from now until the end of the school year. Okay, equation is a mathematical sentence stating 2 things are equal. A mathematical sentence stating 2 things are equal. Mathematical sentence stating 2 things are equal. Some examples. An example of an equation would be like this. Be like this. This is an example of an equation. Example of another one would be just this. Those are all equations. Stating 2 things are equal. Each side of the equal sign are equal to each other. That's why it's, that's why the equal sign is there. That's why they're both, all 4 of those are examples of equations, because there's an equal sign and the equal sign thing on both sides are supposed to equal each other. Now there's 4 ways you can express equations. You can do it in words, you can do it in equations, you can do it in tables and graphs, and we're pretty much going to talk about all these today. The ones we're really going to talk about are probably number 3, the most. Equations some, words some, graphs some, but graphs is going to come more later in the year. Okay, so for sure tables today, for sure regular equations, graphs a little bit, but not so much. But these are the 4 ways that you can show, like, you could do all these things these ways, believe it or not. And I think a lot of people yesterday were having trouble determining the difference between a table and a graph. Okay, so a table is like what you made yesterday for your X and Y chart. A graph is like what you plot on the points. Okay, so knowing the difference between the 2 is important, because I don't want you to graph something where you're just supposed to put a table, or vice versa. Make sure you know the difference between those 2. Alright, so the first thing they're going to do today is they're going to give you an equation. You're like, oh my gosh, this is crazy. It's not that crazy. Equation is t divided by 12. N is the number of messages, and t is the time. Find a table to find out the number of messages in 120, 180, 240, and 300 minutes. Okay, so what you're just going to do is you're just going to design a table. And you kind of did this yesterday with number 32 and 33 with the number of pizza and the cost. Remember the number of the pizza and the cost? It's pretty much what you did already. Okay, so the t, number of messages, right? Okay, so minutes. Where's my number of minutes? Wait, what's happening right now? N is number of messages. T is the time. Number of messages. Okay, so T is the time. So T is going to go here. This is where your minutes are going to go. So 120, 180, 240, 300. T, aka minutes. Probably could write minutes up here. That would have been easier. Okay, and your rule is to take your minutes and to divide by 12. So your rule is going to go in here, and I'm just going to rewrite it. So 120 divided by 12, and then the n is the number of, or the number of messages. Wait, is that right? Yeah, the number of messages that you're going to have. I feel like I have weird numbers and letters up here, but that's okay. So 12 divided by, yep, 10, and then it's going to get into some decimals here. I'm just going to rewrite them all. This one would be 20. Suppose the other ones be 15, I'm guessing. I'll do it in my calculator quick. They're usually not this hard. I don't know why I started one like this, but would be 25. Right? So they're going to give you an equation. You set it up in a table just like what you did yesterday, and I'm going to make it even simpler. It's like what you did with the pizzas. Each pizza is $7. Find out what it is for a certain amount of pizza. So if this is my number of pizza, okay, maybe you have 1 pizza, 2 pizza, 3 pizza, 4 pizza, 5 pizza, and this is the cost. Well, you would take 1 times 7. I bet that's what all of you did yesterday. 2 times 7, 3 times 7, 4 times 7, 5 times 7. Sometimes you don't always need this. Sometimes you don't always need that. A lot of times you need it if you have an like a really big equation. Like if you can do some in your head, you don't need your middle one. That's the last one. Okay, so another thing they're going to do today is they're going to have you guess the rule. So they're going to give you an equation. They're going to give you something. They're going to give you a table that's already done, I guess. And you have to guess what's happening between x and y. So like if I look between x and y, like 1 and 4, what's going on? 2 and 8, what's going on? 3 and 12, what's going on? Well, you could say, well, 1 and 4, I think they're adding 3 every time. Well, does that work for this one? Does that work for this one? No. So you have to find out something that's consistent through the whole thing. So I know my rule would be what? It's times by, not 4. Oh, is it 4? Yeah, it is 4. Times by 4. I was going to say 2. Times by 4. So this is how you would write it, though. There's a certain way to write the equation from the table. So you would take your 3, or not, what do I want to say 3? I don't know why I was going to say that. 4, and then times your x is going to give you what's in your y column. So when you write out your equation, you're going to want to write it the way it's the way it's going to work for every single thing in your table. So if I'm going to take 4 times what's ever in my x, I'm going to get my y. 4 times what's 2, what's in my x, I'm going to get my y. So this is how you would want to write your equation for a table like that. Now this is a pretty simple one. Sometimes they get a little harder. 2 to 5, 3 to 7, 4 to 9. What's going to happen here? No, but it has to be consistent through the whole thing. But some people would say that, yeah. Some people would say that, oh, I'm going to add 2, add 3, add 4, or whatever. But it has to be consistent for every single thing. So you can do 2 things for your rule. If I go to 2 to 5, what am I doing? 3 to 7, what am I doing? 4 to 9, what am I doing? So we know it's not addition. It can't be addition. Because we know it's not addition. It can't be subtraction. You can use multiplication, sure. And you can do subtraction. You can do a few things together. You're close. You're so close. Okay, so then go to the next one. But it's 3 times 3 plus 1 isn't 7. You're getting close. 2x plus 1 equal y. See how it's going? Because Gabe was right. He just wrote it out in the equation format. So if you look at it, it's 2 times 2 plus 1 is 5. 3 times 2 plus 1 is 7. 4 times 2 plus 1 is 9. So you would write it just how you said it, Gabe. 2 times whatever in my x column plus 1 equals what's in my y column. That's right. Nice work. See how kind of what you're going to have to do? You're going to have to kind of guess it. You want me to do another one? Let's do another one. All right. I know, I'm not going to make it too easy. Guess my rule. Guess the rule. Sorry, this is x and y. Rule. We know it's not addition. We know it's not subtraction. What do you think, Landon? What were you saying? Yeah, the number times 3 minus 1. The number times 3 minus 1. The number times 3 minus 1. Good. So you'd write that like what's 3 times whatever in your x column minus 1 what's in my y. Nice job. Way to go. Should we do another one? See if everybody can get it. See if everybody can get it. What? What's the matter? What did you say, Aspen? I thought you said something. Come on, blank page. I'm going to change it up. 2, 4, 6, and 8. Nope. Times 2 plus 2. Good job. Is everybody kind of figuring out how to do something like this? Like, what's that? You're not figuring it out? It just takes a while. Sometimes you don't get it right away. You got to think about it. And even, because this goes 2, 4, 6, 8, it would have been even probably more evident if I would have went 6, 7, 8, 9, like something like that, so I didn't skip a number. Yep. Okay. So how we doing? Okay? Okay? It's not going to be too difficult. All right, so one thing they're going to do is they're going to give you a word form of an equation, and you have to put it in a table. Okay, so here's the word form. The team scores 6 points for each touchdown. This is exactly what you did with the pizza. Okay, so number of touchdowns, number of points. So if they score 1 touchdown, how many points are they going to have? 6. What? Sometimes they're going to skip numbers in the side. You can't just automatically say it's going to go 1, 2, 3, 4. So you got to look to see what's on the side. Okay, so sometimes they might put it in something like this, or they might say, okay, it's 6 times x equals y. They might give it to you. You just have to see what they're doing. Like this is the word format. There's the equation format and putting it in a table. And then if I asked you what the domain and range was of this, what would you say? What's your domain? Because that's your x's, right? So look back in your notebook if you don't remember. So this would be your domain, and this would be your range. Okay? How we doing? So far, so good? Okay. Let's talk about this one. Bob spent 5 more than 3 times what Anna spent. So maybe if it's in a word format, it'd be a good idea if you're unsure to write the rule out first. So what does 5 more than 3 times what Anna spent even look like? What does that even look like? What are some key words in there? More, so we know we're going to be adding. What else? Times. So 5 more than 3 times what Anna spent. Do we know what Anna spent? Well, we kind of do, but let's pretend we don't. So Anna's can be x. Yep. Nobody got? 3x plus 5. You see how we got that? So 3x plus 5 is the rule. This is 3 times more what she spent, and then 5 more. And then now, if I know what x is, let's put it into a table. So if I know what x is, let's say she spent $2. What's Bob going to spend? 11, right? If Bob spends $4, what's she going to spend? 17. 4 times 3 is 12. 12 plus 5 is 17. 6 times 18. 18 plus 5. 23. 8 times 3, 24. 24 plus 5. And that's all. A lot of times today that you're lucky, they have the table set up for you already. You just have to fill in the side. You don't even have to come up with this. They'll most likely have that there for you. So you don't even have to guess what you want to put. You don't have to decide by yourself. They'll have it for you. Let's look at the book. Let's look at the book. Let's look at some of them together to make sure we're all on the same page here. Find page 39. 39. So if I look at, I already used some of these examples, so that's okay. Okay, so look at like numbers 1 and 2. That's exactly what they're going to give you in the book. They're going to set up the table for you already. You just have to fill in, just like what we did on the board. So on that page, 4 through 8, 4 through 7 is pretty simple. All you do is figure out, yeah, it's going to be pretty simple. You figure out what the rule is and then figure out. So if I were you, I would just kind of just redraw the table and just fill in the sides, okay, what it's missing, what it's missing. 8? Yep, question? I would redraw the table. Then it asks you to state the domain and range, and then in the table you can just say this side's the D, this side's the R. So you don't have to list them again. Because either way, you're going to have to list them. 8 looks confusing. One roll of quarters contains 40 quarters. Write an equation that can be used to find the number of quarters, number of rolls. So if there's 40 quarters in one roll, how can you write that in an equation? What if I don't know how many rolls there are? How can I figure that out? How many rolls are there? We don't know. How many quarters are in one roll? 40. So can you figure out if I have 7 rolls, how many quarters am I going to have? Yep. Yep. Don't make it too hard. What else are we going through? No, it doesn't. Make a table. I'll take the graphing part out. How's that? So we don't have to be so sad about it. Get rid of, what's that? I'm just, 8, no C. 8, no C. And then if I look at 12, tickets to amusement park are $26 each. Write an equation to find the total cost for C tickets. And then graph order pairs. How about instead of 12, instead of graphing, we make a table? Make a table. So 1 ticket, 2 tickets, 4 tickets. Let's just make tables. Okay. What else do I have? There's 16 through 19. Oh. Then you should be able to handle 16 through 19. I don't know if you'll get number 18. Try number 18 and see if you can get it. Try number 18. Try number 18. We'll talk about that one on Tuesday. See if you can get it. Do your best. It's not a long assignment today. If you get started, you should be done. Should get close to done. We'll talk about for sure number 18 on Tuesday. Just try your best.